Example 5. A body of mass 40 kg is lying in an inclined plane of slope 30 degrees and it is on the point of slipping down. What force applied parallel to the plane will cause the block to begin to moving up the plane? Take acceleration due to gravity equals to 10 meters per second squared. Looking at the diagram, a mass of 40 kg lying at an inclined plane of 30 degrees, having a normal reaction of R, and the force that is pulling it up the plane as F, and the weight of the body is mg cos theta, and the normal reaction is mg cos theta. Figure 1.8 example, the force that will cause the block to begin to move up the plane is F total equal to F plus mg sine theta. Solution. Frictional force between the two surfaces is given by F equals to mu r, which equals to mu coefficient of friction times mass times force of gravity g sine theta, where mu is equals to tan theta. The coefficient of friction is now tan that, which is equals to 0.5774. Therefore, the force, frictional force F is equals to 0.5774 times 400 cos that. Frictional force we now have 200 Newton. The total friction is now equal to 200 plus 400 sine that, which will give us 200 plus 400 times 0.5, which will now give us 400 Newton. Example 6. A parcel of mass 4.5 kg is suspended from a spring balance in a lift. What does the balance do it if the lift is moving with a uniform speed, accelerating upwards at 0.5 meters per second squared, accelerating downward at 0.5 meters per second squared, taking force of gravity G equals to 9.8 meters per second squared? Solution. Mass is equal to 4.5 kg. Acceleration is equal to 0.5 meters per second squared. Gravity is equal to 9.8 meters per second. Then the tension T is equal to mg. Therefore, tension is equal to force, which is equal to 4.5 times 9.8, which will give us 44.1. B. Mg minus T is equals to Ma. Then mass, which is equals to 4.5 times acceleration due to gravity, which is 9.8 minus T, is now equal to mass of 4.5 times 0.5 acceleration. For 4.1 minus T is equal to 4.5 times 0.5. But 4.1 minus T is now equal to 2.25. T is equal to 41.85. Example 7. A mass of 4 kg rests on a rough table whose coefficient of friction is 0.4. Find the least force sufficient to make it move. Take force of gravity equal to 9.8 meters per second squared. Looking at the figure 1.9 example, a mass of 4 kg is being slided by a force of capital F, and it is resisted by the small f. Then the reaction, which is normal to the body, is R, which is also mass times acceleration due to gravity, which is 39.2. and reaction, which is normal reaction, which is mg. Solution: at sliding force or resistance force small f is equals to coefficient of friction mu times resistance normal reaction r. Therefore, but mu has been given to be 0.4. The reaction r, which is equals to 4 times 9.8 meters per second. Therefore, the sliding force F is equals to 0.4 times 39.2. Therefore, sliding force will now become 15.68 Newton. Example 8. If a force at 10 Newton is just sufficient to move a mass of 2 kg resting on rough horizontal table, find the coefficient of friction taking force of gravity G equals to 9.8 meters per second squared. Looking at the diagram, a 2 kg mass is being pulled by a 10 Newton force, and small force F is resisting the pull. If the normal reaction acting on the mass is 19.6 and the weight of the mass is mg, then we have that the solution: limiting frictional force is equals to resistance force. Limiting frictional force is equals to coefficient of frictional force times normal reaction. Limiting frictional force has been given as 10, is equals to mu, coefficient of friction, times the normal reaction, which is 19.6. Making coefficient of friction the subject of the formula, we have that 10 over 19.6, which will give us mu as 0.5. Example 9. A block is placed on an inclined plane at angle 30 degrees to the horizontal and just remain at rest. Find the coefficient of friction and the angle of friction. Looking at the diagram, a force F is pulling the body, which is having a smaller resistance frictional force. Then the normal reaction R will be acting at a 90 degrees angle. Then if you have to draw the resolution from where the force is being pulled, it will now form a right angle triangle and from the body of mass. We know that limiting frictional force F is equals to coefficient of friction mu times normal reaction R. Making mu the coefficient of frictional force the subject of formula, we have that limiting frictional force over normal reaction. Therefore, tan theta is equals to limiting frictional force over normal reaction. Tan theta is still equals to the coefficient of frictional force. Therefore, tan 30 is equals to the coefficient of friction. Solution B. Looking at this body on an inclined plane of 30 degrees, assuming a normal reaction is acting with mg cos theta, then the force dragging the body down is mg sin theta. Force is equals to F is equals to F. Therefore, mg sin theta is equals to mu mg cos theta. Therefore, making mu the subject of the formula, we now have mg sin theta over mg cos theta, which is equals to, if you do our calculation and cancelling the m and the g, cos over